At the time of its construction in 1883, the Byrd Park Pump House stood as a Victorian-era engineering marvel as pumping technology shifted away from the steam engine and towards water-driven pumps. The pump house supplied the city of Richmond with millions of gallons of water each day. The pump house was strategically positioned between the James River and Kanawha Canal. The pump house also doubled as a public space for the city of Richmond that was the site of many dances and public events. Shown is the only known photo of the pumping machinery. The features of the pumping machinery include the Leffel turbine, penstock, and Cornish valves. In 1924, the water was directed away from the reservoir used by the pump house to the newly constructed hydroelectric pumping station and the Worthington Steam Pump Building. The pumping machinery was then removed and sold to the Japanese as scrap who were preparing for World War II. This footprint was used to piece back together the pumping machinery along with the single existing photograph to construct a 3D model. It is important to note that while only one system was modeled, the arrangement was triplicate, so 3 pumping systems were originally built in the pump house. The historical model, created based on the digital literature, photograph, and drawings, simulate the motion of the pumps. Its operation will be explained in the following videos. The Byrd Park Pump House pumping machinery featured Cornish valves. The Cornish valve was invented in 1820 by William Murdoch. These valves are commonly featured in steam engines during the 1800s and are now obsolete. The pump plungers and pump chambers of the Byrd Park Pump House received and discharged water through double-beat Cornish valves. A double-beat valve, or equilibrium valve, allowed the Cornish valve to be opened against a high pressure using a minimal force. Air vessels were featured over each of the discharge sections of the suction chambers. The spring of the Cornish valve engaged the valve backing and pushed it to or from the valve seat and allowed water to flow through the suction chambers. The Byrd Park Pump House pumping machinery utilized 3 vertical single-acting plunger pumps per system. The plunger pumps were connected to rods that created an up and down motion as the crankshaft rotated. The pump plungers were 14 inches in diameter, and the pump chambers were 36 inches in diameter. The pumps received water from one common suction pipe and discharged water through a common discharge pipe. The Byrd Park Pump House used water-driven pumps to deliver approximately 12 million gallons of water per day. The pump receives water through one common discharge pipe. The pump plunger extends into the pump chamber and moves water through the suction chamber to the discharge pipes. In the suction chambers, the water is controlled by double-beat Cornish valves that act as equilibrium valves to balance pressure. Other valves that drove water through the pump system were gate valves. These were controlled by an operator turning a wheel that guided the water flow.
The Byrd Park Pump House machinery featured rising stem gate valves. These valves are commonly used in water supply systems and are put in line with the pipes to be able to isolate parts of the system while also minimizing loss of flow rate when open. Gate valves are made up of the body, bonnet, and stuffing box, which are in line with the pipes and feature a handwheel, stem, and disc which controls flow. These valves were located before and after the pump chambers and could be opened or closed by turning the handwheel if maintenance needed to be conducted. When valves become closed, the stem retreats into the bonnet and flow is not allowed through the valve. When opened, the stem becomes visible out of the top of the handwheel and stuffing box and indicates water is flowing. Some downsides to the application include throttling, which is not its intended use because of the circular disc section not being an accurate measure of allowed flow. Throttling also creates turbulence, which causes premature wear on seals and should only be fully opened or closed. The rising stem can also accumulate dust and dirt and wear seals within the bonnet as it is opened and closed. These are still widely used today for their simplicity and ability to recognize if they are open or closed due to the rising stem being visible.
While being the driving force of the entire pump system, the Leffel turbine also made the Byrd Park pumps novel and unique. Research revealed that the James Leffel Company began operations at Springfield, Ohio in 1862. They emerged into the turbine market with their double wheel design, which combined two Francis wheel styles into one unit. This design, coupled with the recent invention of the wicket gate, resulted in a system with an efficiency of up to 93% and a specific speed of up to 102. For context, competing wheels were running around 80% efficiency and specific speed around 40 at best, with specific speed being a unitless value of turbine performance. Based on illustrations discovered in a catalog published by the company in 1894, coupled with the single photograph of the Byrd Park pump, the team was able to determine the exact style sold, the turbines used, the type of discharge, and the drive assembly used in the original design.